All right, so welcome everyone. This is a data literacy class for graduate students. If you're not a graduate student, just don't tell me. You're welcome to listen in. What are we going to cover today? Well, this is part of a series of workshops put on by the library. This is the very first one. On Thursday, we'll cover in more detail some data management tips. Then next week, some data wrangling and data visualization, and then finally, data sharing. All of them will be recorded and posted on our YouTube channel, so you can check there if you happen to miss any. But we do ask that you register because that's how you'll get the Zoom link. I will be sharing these slides, so any links I post in them, you can get afterward. If you've registered, I have your email and I'll send them out after the call. So this is our data services team. There's 4 of us right now covering GIS, data management, data sharing, and we're also in the process of hiring 2 more as research data just becomes ever more important. We have 6 core services: data exploration and visualization, data management and sharing, data sourcing, digital humanities, GIS, and 3D and extended reality. We've got our research studio situated in the 1 floor down in Olin Library, in that back corner where the exploration room is. In that research studio, you can use it as a study space. You're welcome to do that. But also the desktops in there have specialized software for working with data. That's especially for ArcGIS Pro, which is only available on a PC. You can access these machines in person, but you can also remote into them at any time by reservation. And there's more info on our library page. And we also run a help desk service. So you can drop by in person or come on Zoom. We also take by appointment requests. Again, info is on our website. You can email us a question, however you want to get in touch with us, and we'll try and answer. And if we can't answer, we'll find someone who does. So what are we going to cover today? A little bit about sort of what is data literacy and why you should care, how to find and evaluate data, data management plans, and data sharing and ethics. The last 2 we'll just touch upon briefly, as some later sessions will go into more detail about those. All right. So what is data literacy? It's really the ability to find, evaluate, understand, analyze, and make arguments with data. You can think of it as your critical thinking skills around data. And what I'm talking about today does not require any special coding skills or knowledge of statistics or higher math. It's really just bringing a critical approach to evaluating and communicating with data. So why does being data literate matter? Well, you want to sort of give context to your data. You want to build on existing discoveries. You want to be able to make arguments with your data. You want to able to show your methods and data and stand behind them and design a reproducible research project that stands up to peer review. And so what happens if you don't do it? Well, when you're not managing your data well, you're redoing work unnecessarily. You're making data arguments that might lead to faulty conclusions. Worst case, you end up having to retract faulty research. And also just, hidden data is not useful. It can weaken your findings and your data can't be cited, which of course helps you in any sort of promotion or tenure or recognition. So we want to be contributing to the advancement of research, and being data literate and managing our data well helps us along that path. So one of the first things is just understand the data lifecycle. The data lifecycle is a lifestyle. So what are we talking about here? There's lots of different lifecycle models. This is one we've chosen to focus on. But the important thing is these are just sort of big picture stages of your research process. So first we start out the planning stage. You're generating ideas, you're coming up with your hypotheses, you're applying for funding, you're trying to figure out what tools or methods you might use, you're looking for collaborators, and you're writing your data management plan. Then you're trying to acquire your data. You might be sourcing it from a couple different places. Primary data is the data you've collected. And secondary data we refer to as that you might have gotten from another source, like census data, for example. Then you're evaluating your data for completeness and suitability for your project, and you're getting it organized so that others that you work with can understand it. Then you need to combine and prepare that data for analysis. This is sometimes called data cleaning or data wrangling, data munging. There's lots of words for it, but basically you're getting it in shape to use it, because there's no such thing as clean data. And now you're analyzing it. You're using tools or scripts. You're looking for relationships or structures. You're identifying biases. You might be making inferences. You're producing statistics. When you're preserving data, you're keeping it secure, backed up. You're keeping track of your versions. We always recommend people use open, non-proprietary file formats for sustainability. So that's why I think little things like using a CSV instead of an Excel file, all those little things make a big difference down the road. Then you're getting ready to share what you've come up with. You might create some visualizations to show off relationships and findings. You're communicating via publication, or you're depositing your data in a repository for preservation and access. And then at the end of all this, you and others can reuse that data to further research and help your field grow. Now, what I just presented is this very idealized sense of the data life cycle, and it's very familiar to you as a research cycle. In real life, it looks like this. On the right, you're repeating steps, you're going back on yourself, you get new data, you process it, then you realize you need more data, and you go back and you reprocess it, you analyze it a little, then you go back to plan, you refine your hypothesis, you refine your methods, and you go back and forth, and maybe you end up going through any number of these steps any number of times. So again, I'm presented you somewhat in an ideal just to give you a sense of the different steps. But just know if you're not proceeding in this nice, orderly manner, don't worry, that's perfectly normal. And in fact, I would be surprised if you were proceeding in a nice circular manner like this. All right, so what's a data set then? Really, we think of it any set of information that can be stored in a structured or standardized format. And it can come in any number of forms. So there's text and geospatial and numeric, computer code, 3D data, audiovisual. So text data, maybe some of you are analyzing social media discourse. That's text data. Some of you might be in literature and analyzing Victorian romance novels. Numeric data is probably one we're all very familiar with. Ever opened a spreadsheet? But there, any kind of things that could be used for audiovisual. We might study people's affect in a recording. We take oral histories. We are studying acoustics. So any number of things there. Geospatial is something the data services team specializes in. And then 3D data and computer code as well, or other formats. Really, anything that you're touching in your research could be considered data. So we have human versus machine readable data. Human readable data is pretty obvious. We can read it, and it's usually something like a PDF or a Word doc or handwritten notes. While machine readable data usually has to be structured in some way to be read and processed by machines. Now, one of you is going to be hyper-technical with me and say a PDF is machine readable, or I could always OCR something. And you're right. I mean, that is taking something, words, and formatting them into machine data. But really, we want, when we talk about this, we talk about the data being structured in some way. So it might be as simple as keyword value pairs, like in JSON, or it could be a CSV table, could be markup language of one kind or another. And so if you look at this example with this receipt, that's both really human and machine readable, possibly. Human readable, we all understand what's happening here. Someone has ordered some food. We can see the total amount, how many they ordered, how much is tax, and so on and so forth. But if you wanted to pile all these receipts together as a restaurant owner and figure out, how many muffins do we sell by 11 a.m., you're going to want all those receipts in a different format. And you're going to produce at a minimum a CSV or have some sort of database of all of your sales. So that's something that then turns all those receipts into machine readable data for processing that. So why do we use machine readable formats? Well, for one thing, we can store large volumes of data relatively cheaply. Storing in machine readable format makes it really easy to share and reuse both with other humans and machines. So think how easy it is nowadays to just send a PDF around the world rather than having to buy a book. And then, of course, computational tools can just process huge volumes of data that can be difficult or tedious or time consuming for humans to process it all. And best case scenario, machines can find patterns that humans might miss. So you're all probably using machine readable formats already. In our next workshop on data management, we'll talk about how to organize your files, how to optimize those machine readable formats so that you're working efficiently. But for now, I want to get back to sort of some types of data that you'll see. Because understanding the type of data you're working with will help you prepare your data for analysis and select the appropriate data analysis tool for your research. So you may have all learned this already in a stats class, but I think it's worth going over. If you had the stats class, and if you never had stats, though, then it's also worth going over. So really, big picture, we're looking at quantitative data, numeric typically, and qualitative. So qualitative data are things that really can't be counted. They're descriptive or categorical, like labels or text. It's usually the quality of an object that's being studied that you can't experimentally measure. And so typically with quantitative measurements, we're looking at lab measurements or sensor readings. They might be derived from existing sources. You can apply statistical methods to those sorts of things. And quantitative data, we usually talk about it being discrete or continuous. And discrete data are basically things that can be counted, okay? And that you can't break them in half. So counting humans population data would be discrete. We never say the population of the United States is 350 million, 0.5 humans. That's an example of a discrete data type. And then continuous is more, well, you can think of it as those are things that can have another decimal place. And then continuous data itself is broken down into interval and ratio. So interval data, you're thinking about things like distances where there's not really a true zero, and ratio data tends to be a range of things. So temperature might be an example of an interval data type, whereas say salary ranges are in a sort of fixed increments are ratios. And then in qualitative data, we break that down into nominal and ordinal data. So nominal data is like categorical data, like hair color or colors in general. And then ordinal data is usually ranking data. So any of you worked with the Likert scale, dissatisfied, very dissatisfied, dissatisfied, neutral, 1 to 5, that's ordinal, classic ordinal data. And you see this often in the social sciences, any sort of survey data, interview transcripts, that sort of thing. That's a very common ordinal data. Now, there's actually some tricky ones. Are zip codes qualitative or quantitative? Well, they're numbers, so the temptation might be to call them quantitative. But in truth, it doesn't really make sense to sum up a zip code column or take their average or anything like that. So in fact, those are qualitative. They're categories. Likewise, with colors, you might think them as categories or nominal data, and so red is a category. But if you're a scientist researching the color spectrum, The RGB numbers you apply to numbers might mean that your color data is in fact quantitative. So don't worry if this doesn't make sense now, or if it's boring and you had it already. I just want you to appreciate right now that there are differences to the types of data you'll encounter. Now, why bother with that? Well, it's important to understand what you can do with the data. So you got to understand what the data types are. So when you have quantitative data, you can do all those statistical things like mean, median, mode, range, calculate standard deviation, that sort of thing. But they don't work with qualitative data. Qualitative data, you end up doing things like frequency tables. How many times was this word mentioned? How many times did we get, dissatisfied in our question responses? Sometimes sorting makes sense, sometimes it doesn't, because there's no hierarchy to things. So these are all the kinds of things. If you're getting weird results, think back to your data types and determine if you're using the wrong method for the data type that you have. The other thing that's really important for you to do is learn to recognize sensitive data. So sensitive data is anything that's restricted by law, university policy, or ethical considerations. Might be confidential data, personally identifiable information like social security numbers, protected health data, or really any information that puts research participants or locations at risk. Now, this is true for any discipline. I don't want you to think that only people in medicine have to worry about the 18 HIPAA identifiers and that's it. Really, any discipline can encounter sensitive data of one kind or another, and it's important to just be on the lookout for it in what you're doing. If you're working with humans of any kind, human subject data is sort of always sensitive. Think about, are you working with minors? Are you working with minority populations? Are you putting them at risk in disclosing their names or habits? If you work with endangered species or in archaeological digs, are you putting those species or locations at risk because you are publishing about them? So really always sort of have that in the back of your head as you're reviewing material. Do I have to worry about sharing this data down the road? So when you have sensitive data, it determines how you should store your data, whether and how you can share it, and protects your research subjects' privacy. And of course, last but not least, helps you comply with any legal and ethical obligations. You'll find more information on working with sensitive data, various places on the WashU website. So the information security team has a list of the types of protected data, and then they also offer different storage options for what kind of data you have. So don't put any sort of sensitive data in Google Drive, for example, and then they have other solutions you could use. And then also the Becker Library for the medical school has more information on human participant data considerations. Okay, now I'm going to move on to finding and evaluating data. First of all, there are plentiful data repositories out there. We have a research guide in the library. You can ask us in data services, or you can ask your subject librarian. They often have good recommendations to where to find things relevant to your discipline. There's also a repository of repositories where you can sort of browse by domain looking for things. And this is a good place to find data that's authoritative. There's also dataset aggregators. So in addition to regular Google search, not everyone knows about Google dataset search. So just put dataset in front. So that produces datasets and not just the academic articles. There's generalist repositories out there and disciplinary repositories out there. There's many, 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 many. And what makes sense for you is very discipline specific. Other ways you can find data, start poking around websites, go deep, government agencies, NGOs, private businesses or industry groups, other academic researchers. you're reading a scholarly article, you can't find their data set, you're in grad school. You should feel free to email the author and ask for a copy of their data set. And if they've done it well, they should be able to track it down easily and send it on to you. Their government reports, or really what we call in gray literature. So reports, working papers, white papers, produced sort of outside traditional academia publishing channels by NGOs or trade associations and businesses. Okay, so what are you looking for when you think you found a data set? How do you know if it's any good? Well, is a source authoritative? So an established research entity, an NGO, a government body. So if you haven't, don't just say I've never heard of them before, do a little bit more research than that. But that's one red flag. Some NGOs might be more established than others. Red Cross data has a long history. That's going to be a little more authoritative than some other NGO that started last month. Then you need to look at, do you have the right to reuse the data? This is very important and can get people in trouble. So look at the license. There might be a Creative Commons license or an open data license. There might separately be a data use agreement. You see this often in labs. And really look for any restrictions on confidentiality, resharing, or commercial use. And then, because you're in grad school, I want to call this out. Consult your PI whether you can use lab data in your dissertation or publication, because the last thing you want to do is be in the last year of your dissertation and your lab PI says, we're not ready for you to use that data, and now you've all of a sudden lost one of the chapters in your dissertation. So make sure to talk to them and make sure you can use it too. So what else are you looking for? You've got an authoritative source, you've got the right to use it. What are the kinds of things you're looking for? Well, look at the motivation or bias behind the study. Who's paying for it? Are only successful trials being published? Look at your own confirmation bias too. Are you only looking for data that supports your hypothesis, or are you willing to look closely at data that negates your hypothesis? Look at the sample size. Is it too small to be useful? Look at how people are recruiting participants. Was the collection done ethically? And look at the variables. Is there too much missing data? Do they explain the units of measure? The last thing you want to do is find out that they're using kilometers and you're using miles and everything is chaos. What level of measurement are they using? Are they using raw proportional values? Understand their margin of error, and understand false precision. This is something, of course, you see in advertising all the time. Our product is twice as good as the competitor. I mean, I don't even know how they measure that. But it also comes up in scientific measurements. A lot of times when you're converting from one measurement unit to another, and it goes out to 4 decimal points. Well, sometimes that's just a false precision that's not that meaningful in the end. All right, so let's try and understand what makes data set documentation good. They're going to explain the source, the purpose and method of collection. They're going to describe the variables and unit of measurement. They're going to have a file inventory, and they're going to explain what processes they use in any data cleanup and analysis. Data without documentation makes it data that's difficult to understand and difficult to share. So you'll typically find data documentation in one of these 3 types. In the data management workshop, we'll tell you more about creating these files, so I won't go over it now, but just want you to be aware of that they're out there. So there's README files. They describe the data collection, a preferred citation, file names, variable names, that sort of thing. A data dictionary usually is a bit more, usually looks like a spreadsheet, and it's got a list of fields in the table, what they mean, the units of measure and the precision, and a range of allowed values. And then code books in particular are used in qualitative researchers to provide information about data that's usually coming from a survey instrument, one kind or another. And they explain sort of the response codes or classifications and other information. And if you're using something like REDCap, they can generate codebook for you, so that's useful. So whenever you're using someone else's data, you should provide a citation just like you would for any other resource, and you should be using the citation style appropriate for your discipline. But it's gonna, include the usual things: author, date of publication, title, publisher, and the DOI. The optional but highly recommended in the case of data sets is addition or version if there's more than one, and also a file format. That's not something you necessarily see in written work. Sometimes if you're lucky, you'll get like a recommended citation. You won't always though. So here's just some examples, and you can see more from DataCite as well. Again, I'm handing out the slides so you can refer back to this if you need to. Okay, now I want to talk about data management plans. You've got a research idea, you've started collecting data, you've applied for funding, and they're asking for a data management plan. So how do you go about doing that? Well, a little time now is going to save you a lot of time later. And the current you is the future you is going to love current you. And not just you, but your lab mates and future researchers are going to love all the data management that you did on day one. So why develop a data management plan? So whether or not it's required when applying for a grant, effectively organizing your data has benefits. First, it helps you understand your data more easily, both now and in the future when you haven't worked for it in a while. So this happens all the time to me too. 6 months from now, I put something down. 6 months from now, I pick it up and I say, where was I? And I can't remember column F, and the column name I gave it is obscure. And even I don't remember what column F was trying to capture. That's the kind of thing we want to avoid. And that's only 6 months. So imagine 3 years from now when a new postdoc joins the team and they have no idea what column F is. So that's why we do these sorts of things. So helps maintain continuity through staff changes on the research team, helps maintain data integrity and reduce the risk of lost, stolen, or misused data, facilitates validation of results and reproducibility, and facilitates sharing and therefore greater collaboration and impact. And again, another time saver, reduces the time to write up your research results. As your project progresses, you may find it necessary to revisit your data management plan and make changes, and that's fine. It's never too late to develop a data management plan and make tweaks to it as you go along. So how might you do it? There's a wonderful resource out there called the Data Management Plan Tool. And we subscribe in the library to the DMP tool, and it helps you use boilerplate language to fill in the fields that a funder might ask for. Each funding agency has sometimes unique criteria, and so that's why the DMP tool was created, because it allows you to select the relevant funder and gives you sort of the questions that they ask and helps you fill in the things. So generally speaking, they're going to all ask you one way or another, what are you collecting? How will you store it? How will you organize it? How are you collaborating? How are you documenting all this? How are you protecting it? And how are you going to share it? So the more you do at the planning stage, remember the 12 o'clock on that circle earlier, the easier it'll be to share later. So here's what the DMP tool looks like. When you log in, you'll log in with your WSDL key, and that gives you access. And you'll see right away, there's some little help links to either Olin Library Guides or Becker Library Guides for the School of Medicine. Your dashboard shows all the DMPs you have done. So ask you to create a new plan. Your research organization is WashU. You select the primary funding organization. Well, it's a drop-down list. Let's say you can find National Science Foundation. Yes. And then you can find which subdivision of NSF applies to your grant. then prompt for what the DMP should include for NSF grants. And then you see on the right some guidance that you can refer to if you need to fill in that section. Here's another section, period of data retention, for example. And then period of data retention, we in the library have developed some stock language that you can use to populate that paragraph. If you're depositing in the WashU data repository, this is what you would need to say in that section, and we've written it all out for you. Do double check what's there, because there are options to pick from, so it's not just a pure blind cut and paste, but hopefully it gives you some language to start with, things to think about as you fill this out. We use the data site metadata schema. That's where we get our DOIs from. And then this is another great resource. You can get feedback from us. So it's either us in the Olin libraries or the Becker library. We will, if you ask us, we'll review your data management plan and give you some feedback. Then you can download it and use it as part of your grant application. So the too long didn't read of data management is have a plan, be consistent, create documentation, and back everything up. If you can do those 4 things in the way that works for you, then you are well on your road to success. Okay, I'm going to take one little deviation before I go into data sharing. ORCIDs. An ORCID ID will link your publications or other research activities to you. Some of you might already have an ORCID. If you don't, I want you to stop listening to me and go get one now. I won't even be offended. It takes 1 minute to set up your account. And it's basically a unique identifier for you as a researcher. So firstly, it's increasingly required by funders and publishers. It gives you full power over sort of claiming ownership of research outputs. So if you have a very common name or you've changed names over the course of your lifetime, the ORCID ID can sort of tie those things together to say, this belongs to this John Smith and not that John Smith. But even if you think you have a unique name, and honestly, you might not, because I was working with someone who thought he had a unique name, and we went in there and there were 5 others with that name. So it also really helps you with saves time on repetitive data entry when you're dealing with funders and publishers, that you can sort of link out to all your research by just sharing your ORCID ID. So it's something you should do right out of the gate as a graduate student if you have not already. All right, that was a little digression. I'm going to move on to data sharing and ethics. So data sharing is a responsibility. Most funders require a data management plan and data sharing at significant milestones or at the end of your funded projects. So especially true of federal funders, but they're not the only ones. Data management plans are almost always required. And even if it's not required, it's just a really good idea for the sake of the project. You should be thinking about this. And you should be thinking about this, honestly, even if you're a solo researcher, because it's just organizing your data and saving yourself from pain a couple months from now. You know, the dissertation is a long project. Getting your files organized will help you finish that off. So data needs to be deposited in a data repository of some kind with a persistent identifier, which almost always means DOI, and robust metadata. Federal policy wants to improve public access to federally funded research results. So the idea being that, you know, taxpayer money has funded this. Why can't taxpayers see the results of these? And so results should be made freely available and publicly accessible by default at the time of publication. Sensitive data should be de-identified and or shared in a restricted repository, but as much as possible, the default is to share publicly. Considerations when sharing data are data documentation, data reuse, getting that persistent identifier, data review, data replication, transparency, balanced by protecting sensitive data. We also have, there's a polling out there that indicates that Americans are more trustful of science when the data is openly available. So when data sharing, our goal is to make data fair. And so FAIR stands for findable, accessible, interoperable, and reusable. So findable means put it in a repository. The funders want it in a robust repository. So that could be the WashU research data repository is an acceptable, meets the federal standards for a repository. There are also disciplinary repositories out there. Accessible means use open protocols, metadata and data can be accessed. So not ideas that's not hidden behind a paywall. Interoperable, we want to use formal, standard, open languages as much as possible so that the most people can use them now and in the future, and then make them reusable by documenting them well, explaining their provenance, using an open license. Earlier, I talked about some available data repositories when looking for data, and here are some for depositing data. There is the WashU research data repository, Word, where you can submit things and then the data services team curates them to ensure fairness. So we'll give you feedback on how good your README is and that sort of thing. And we will mint a DOI for you that will stay with that data set. And then that R3 data repository I mentioned earlier is another good place if you, for whatever reason, aren't submitting to the WashU research data repository, you can find a disciplinary repository there. So how can we help you with all this? Well, we can help you on advising on repository selection. Sometimes, you know, we don't demand that everything go in the WashU one. Sometimes a disciplinary one makes more sense. They can handle your unique data type, for example, or they can handle sensitive data, for example. That's perfectly fine. And whether you use our repository or not, we're happy to review your data and your documentation and your data management plan. We'll provide suggestions to you on how to improve the data fairness and help you sort of prepare any sort of documentation around your data. So really, there's three overlapping units on campus that really help with data sharing. There's us in the library and data services. And then there's the Beckel Medical Library, has similar information about data management and sharing. They have a special emphasis on human participant data. So that's a good place to look whether or not you're in the medical school. And then the Office of the Vice Chancellor for Research has a data landing page. That's especially important to review to look at any legal obligations or university obligations around data management and data sharing.